Hello students, in this video we will learn 9th class physics 2nd chapter force and laws of motion. So in this chapter there are two quantities, force and motion. So motion we have studied in previous chapter. Now be ready for force. So now see what is the force. In the case of force we can say that a pull or a push that is plotted on a body is called force. A pull or a push that is plotted on a body is called force. Suppose here is a body A. You are applying a push. Otherwise you are applying a pull on the body. It means you are applying force on the body. If you are applying a pull or otherwise push on the body, it means you are applying force on the body. Note, in the case of force we can say that, note, in the case of force we can say that force is a factor, force is a physical factor that brings the change upon static or motive state of a body. A force is a physical factor that brings the changes into motive or static states of a body. One again, a force is a physical factor that brings static or that brings change into motive or static states of a body. One again, a force is a physical factor that brings the change into motive or static states of a body. How it happens? See this. Suppose here is a car. So if you will apply, suppose car is stubborn. Suppose this car is stubborn, and you are applying a push, so the car will come in motion. After that, otherwise you are applying a pull. That time also the car will come in motion. First thing. Second thing. But suppose car is in motion. Car is in motion. And you are applying a force in the opposite direction of the motion. You are applying force in the opposite direction of the motion of the car. It means car will come in stable. Due to applying force, the car will come in the state of stability, state of static. So we can say that force is a physical factor that brings the changes into static states, otherwise motive states of a body. Now, it happens that mathematical representation of force. Mathematical representation of force. Mathematical representation of force. Force applied by a body becomes equal to the magnitude of the mass of the body and the rate of change in velocity of the body. Suppose here is a body A. It applies force on body B. Suppose a body A applies force on body B. So the force applied by body A on body B will be equal to the magnitude of the mass of the body A equal to the magnitude of the mass of the body A, and due to colliding the rate in change in of velocity of body A. So how it happens? See this. Force applied by a body on other body. Force applied by a body on other body, it becomes equal to the magnitude of mass and rate of change in velocity of the same body. So, in this situation, it happens that suppose body A applies brake on suppose body A applies force on the body B. So the force applied by body A will be equal to the magnitude of the mass of body A and rate in change of velocity of body A. That takes place surely if A strikes with B. If a body strikes with another body, so it is must that its velocity will be changed. And if the velocity will change, so this change will take place on a particular rate. So how it happens? See this. Force applied by a body is equal to mass of the body into rate of change in the velocity of body. Force applied by body. So if force applied by a body is represented by capital F, mass of the body represented by small. So if the force applied by a body is denoted by capital F, mass of the body denoted by small m, and the rate of change in velocity is denoted by the V by T. So it means force applied by the body, force equal to m into the V by T. Suppose equation 1. Here del means change. Del change. So force applied by a body is equal to the magnitude of the mass and rate of change of velocity of the same body. By this. Now, unit of the force. Unit of the force. Unit of the force from equation 1. Unit of force is equal to unit of mass into unit of velocity. Here change in velocity, so unit of velocity, otherwise unit of change in velocity is the same thing, upon unit of time. So unit of force is equal to unit of mass is kg into unit of velocity meter per second, meter upon second. Into unit of time, second. So, but unit of time, it is written down in denominator. So, I will write here unit of time, second. So, now kg into meter per second into 1 upon second using notations. So, kg into meter upon second is square. So, I can write that kg into meter into second to power minus 2. That is the unit of force. Now, and this relation is also known as Newton, denoted by capital N. So, we can say that unit of force is Newton. So, we can say that unit of force is Newton. Unit of force is Newton. That's all. In next video, I will tell you effects of force and some numericals related with the force. Thank you.